Hello, and welcome to this webinar on operationalizing machine learning using the Oracle Autonomous Data Warehouse and the Oracle Autonomous Transaction Processing Database and the Oracle machine learning algorithms that are embedded in both. My name's Charlie Berger. I'm the Senior Director of Product Management for Machine Learning here at Oracle, and this presentation is actually the aggregation and culmination of a few different sort of collaborative activities I've been working on. Brendan Tierney I co-presented with at Oracle Open World 2019, and you'll see his contribution in the deployment portion of this doing the REST API services, and I'll show his materials at the end. He does it better than I, but I'll do my best to cover his materials there. And he's a most excellent Oracle ACE director and author of books and so on. So do refer to Brendan for any more details on that. Also, some great work by Devani Sheth and Sadesh, both solutions engineers who have done some great work on the contributing for the reviewing of the results that we generate through Oracle Machine Learning, viewing those results using the Oracle Analytics Cloud. So with that and acknowledgement to all my collaborators, great collaborators, I'll dive into the details here. The key here is that the punchline, I guess, is that with Oracle, we move the algorithms to the data. We have embedded about 30 plus machine learning algorithms into the kernel of the Oracle database, so they do all the processing inside the database. We expose them to of course, to SQL, their native language, their SQL functions actually inside the database, so benefit from all the parallelism and scalability and security and everything else that goes along with the database. We also expose them and publish them through the Oracle Machine Learning notebooks that come with the autonomous databases. We expose them through the Oracle Data Miner drag and drop GUI that's an extension to SQL Developer. We expose and integrate them with the open source language R through something called Oracle Machine Learning for R. And we will, in the very near future, in early 2020, be integrating and exposing them also, so you can call them from Python. That'll be called Oracle Machine Learning for Python, and that'll be available in early 2020. And like the integration with R, the integration with the open source languages also enable you to be able to do callouts to packages that are available in the open source community. Now, you do pay a little bit of a price there because you move the data out to the open source, but you can do it, and you can really extend the offering quite a bit. And hopefully, most of your problem solving is handled by the 30 plus powerful and very capable machine learning algorithms in the database. And what I'm going to do is walk you through a very simple example. So let's get on with it. Oracle always requires us to show a safe harbor statement that just says any future statements about futures to sort of not take it as a commitment to deliver any material code or functionality. Brendan and I are both active on Twitter. You can follow us on Twitter if you're so inclined. You'll see some of our material and links and different information from time to time. So I encourage you to follow us if you can. And the example that we're going to use today is picking a good wine for as cheap as we can get it. Basically, I say under $20, but it's really whatever you can get away with, as cheap a wine as you can get away with, using the Autonomous Data Warehouse, the Autonomous Transactional Database, machine learning, and the Analytics Cloud. So we've all been there. We get invited to a party. Maybe we don't know the other people at the party that well. We want to bring a bottle of wine, but we don't want to spend too much money on the bottle of wine, right? We don't want to spend $50 or $100 on a bottle of wine. We barely know these people, right? Or we're not that close, and we just want to show up with a good bottle of wine that we can kind of say, have everyone be impressed that, wow, Charlie brought a good bottle of wine. That looks pretty good. But we want to pick out a wine that's predicted to be a good wine. It may not have a wine spectator review of 95 points or something like that, but it looks like it could be a good wine. So how are we going to do that? I'm going to share through the course of this presentation and demo a simple autonomous database and Oracle machine learning use case. We're going to have already imported the data just using the SQL Developer connection to the database. We're going to explore the data a little bit in the autonomous database using the Oracle Machine Learning Zeppelin-based notebooks. We're going to identify the key variables that are most predictive in nature. We're going to build a predictive model. We're going to apply the model. And then what are we going to do? We're going to leave the results right in the database So we can come back and use a better visualization and investigative kind of visualization drill down kind of tool to kind of go back and look at those results. And we're going to use Oracle Analytics Cloud to do that. And then we're going to deploy the models, because once we have a good model, it would be nice to kind of operationalize this model, put it as a REST API call or something that I can call from my Droid as I'm walking through the store or whatever I'd like. I always like to show over on the right-hand side this sort of logical flow of what we're going to do, because I do think for a lot of IT professionals and Oracle data analysts and Oracle SQL professionals, there is a natural migration, a natural career progression to go from, just simply running the engine in the back room, keeping the database up and running. And now as the autonomous database automates more and more of those tasks, it frees those talented individuals up to be able to do so much more with their data skills, their knowledge skills. And I'll kind of walk you through that here, where we define a business problem, we kind of understand our data, maybe we do some little bit of data preparation. We're going to go very light on that in this scenario. We're going to build a model. We're going to evaluate, is this model generally a pretty good model, and then we're going to deploy the results. So let's get on with it. So in the Oracle Autonomous database, it comes with quite a number of algorithms. So here's the whole listing of everything that's available on premise. Currently, at this very moment, the R and the Python, the open source integration. I know I'm showing R over here, but that will be available in 2020, and the Python integration and all the Python packages that we are able to make callouts to and all of that will also be available in early 2020. But think of it as the core SQL functions here today, and you also have these REST API calls that you can use through ORDS today as well. So let's go use some of these algorithms. What I'm going to do here is I think I'm using a random forest through this, one of the classification techniques, and I'm also going to use an attribute importance, where we're going to try and find what are the key variables that are driving that are most associated with a good bottle of wine. So let's continue on. Oh yeah, also there's a number of statistical functions that come with the database. Descriptive statistics, t-test, f-test. I always find that people are quite surprised to learn that there's Pearson's correlation coefficients and Kendall's tau and chi-square, and quite a few statistical functions that are parallelized SQL function implementations inside the Oracle databases, and these are available for any kind of basic statistical work that you may do, and you don't always have to take the data out to some other dedicated statistics package. If you see what you need here, you're good to go. And so what we're going to ultimately do is use this sort of syntax. If I have a GUI, I would use a GUI. We're going to use the Oracle machine learning notebooks that are SQL notebooks. So I'm going to have SQL code that I'm going to write, but also roadmap-wise, this is one of those features. We also have a very automated code-free GUI called AutoML user interface that's coming along in, as I said, early 2020. So, but every GUI underneath the GUI is code, right? So I'll show you how we do that. So the code that we're going to do is this begin DBMS data mining create model. The name of the model is going to be a wine classification model. So we're going to classify wine as either good, and my definition of good is going to be very straightforward. It's going to be, in wine they have this ratings scheme, between, I don't know how low it goes, but you want to get as high as you can to 100. If you can get a good bottle of wine at 92, 93, 94 points, you're doing really well, for $20 or $30. So they also go down lower into the 70s, 80s or so, I suppose. And what we're going to do is we're going to define a cut point. We're going to say if it's 90 points or above, it's a good wine, and if it's 89 points or below, it's not necessarily such a good wine. So we're going to use previously classified data, previously tagged data that's been labeled as good wine, bad wine, to build a model on that data. We're going to use this wine training data. The target field is going to be this points bin. I've binned the points field into good wine, not so good wine, and I'm going to have some model settings for like the random forest, the decision tree. Those are things that all come with defaults, but I just want to kind of point out that's what we're doing there. So we're going to run this. We're going to build a model, and also one of the things I always like to call out is when you build a model, how do you know that's a good model? Well, when we build the model, we usually go through the process of having a 60-40 split, right? So we'll take 60% of our data that we're using, our historical data, and we'll build a model. but then we'll have a holdout sample of another, say, 40%, and we'll test the model. We'll actually make predictions on the past, and we'll see how accurately we can predict if it's a good wine or a bad wine. And if we get 80, 85, 90% accuracy, we're going to say that's wonderful, and we're going to make that leap of faith to apply that model with that amount of accuracy to any new records of data and make predictions. So now, whether I'm doing this from a REST API call or just a batch call or a SQL transactional autonomous transactional processing database call, I can just say, well, here's the type of model. It's $25. It's a Malbec. It's from Spain, and make a prediction on this. And that's what it really boils down to. So I have a notebook that I've created. It's this wine reviews data notebook, and I'm going to go through this process, but I also have that sort of live over here. So I'm going to see if we can, I've got all PowerPoints in case anything breaks down on me, but I'm going to see how far I can get with the live here real quickly. And I'm going to go over here to the live notebook. So here's my notebook, and I do want to point out in the Oracle Machine Learning a little bit of a few other things here, right? I can run a SQL statement, a script. I have various different notebooks that I was just showing you before, and there's all the notebooks. And the one I'm going to be using is this one right here, Predicting a Good Wine, and I just was working on it today, or updating it just a little bit. And I have different projects over here as well, so I can come in here and say, well, I have a different project. Which project is it? I also have different workspace permissions that I can set up. So I have different workspaces so I can collaborate with different people. And as you heard in our roadmap, we're also adding support for Python languages, and then after that, the R languages. So you'll be able to have, different members of your data science team all sharing the same notebooks and working together. We also have templates that if you have a personal or a shared, any kind of templates, you can also use those. Let's say I build some really good example templates for classification models or some sort of problem solving in my particular company. I can share those with others in my group or enterprise wide. And we at Oracle have created a number of different notebooks here already for you. So if you want to go off and do something like a classification here, well, we have an example notebook, and I've used this example notebook, bits and pieces of it, to do the wine reviews notebook. So in this notebook, we predict customers that are most likely to be positive responders to an affinity card loyalty program. And as you go through here, you kind of see what we're doing. And we're going to do something a little bit similar to this in our wine predictions notebook. So that's an example for you. And there's different ones for doing different types of associations, classifications, and so on. But I'm going to jump back to our main storyline, which is picking a good wine for as cheap as we, under $20, $10 if we can, right? So we're going to try and see if we can see a good wine out there using some historical data as a reference. Now, I also want to point out a few different things here. I can export this notebook by clicking on that. I can clear the output. I can show the code. This is right here is Markdown language that I'm doing right here for what I'm writing. And I have these interpreters. So right now we have the SQL interpreters and the Markdown interpreters, and over time we'll add the Python and the R interpreters here. I can also change the width of, that's not what I wanted to show. I can also change the width of my paragraphs here. So if I want to make this paragraph 10, width of 10, I can do that to do a certain amount of sort of layout on here. I've done the best I can with the sort of chunkiness of these paragraphs. And I have a little bit of the storyline. We've all been there. We've been invited to a party. We want to bring a bottle of wine, but we don't want to spend too much, less than $35 certainly. I may also want to put some pictures in here. So there's some little snippets of how to add in a picture. I just wanted to kind of show that because it always helps to have a good looking notebook. You also want to be fairly diligent about documenting things. So we say, well, you can also access this data from Kaggle if you want to. There's different sources of this data, but that's the one I'm referencing. And let's explore the wine. So when we do this, what we're really doing is I should have this. I'm doing select star from the wine reviews, and I have 130,000 records here. Now, when I run this and it pulls up that data, it is actually gonna, in the little paragraph here, gonna really show only about the first 1,000 records. So if I want to change that query to say sort by or select where row number is less than 1,000 or do some clever SQL things, many of you know how to do that quite well, and you can do things like that. But I'm gonna take generally the top 1,000 records here. You can see the number of, you can see the points here, and if I want to sort this. I can see that. I can sort this based on, I think I saw a price over here somewhere, points. So it's a 100-point wine there. That's a very nice wine here. But the price is probably, well, it's where is price? Price is on here somewhere. Price, it's a lot, right? $350. So I probably don't want to pay $350 for that bottle of wine. So what I also can do here is I'm gonna show some simple graphs. So if I take the data here in the notebooks, I can do certain kind of graphics. I could do a pie chart. I just had a bar chart, and it will somewhat remember what I've just done there. And I have the ID, so the count. I can do count, average, whatever. They're just basic graphing capabilities. I don't want to get your hopes up too much of extensive kind of things like you can do in Oracle Analytics Cloud. It's meant for sort of rudimentary basic graphs that you would use associated with getting to understand your data and being able to run off and build some models. We're also going to display the data based on count by wines by country. So you can see the number of wines, group by country, and order by the count. And I only want to show the first 10 because I don't want this thing to scroll off forever. But a lot of wines coming out of the United States, a lot out of so what 62,000 wines out of that 130,000 wines are in the United States, 21,000 out of France, many out of Italy, and so on. So those are where the main wines are coming from, to no surprise. And if I want to see that also as a pie chart, I can do that. I can also do sort of interactive things like include or exclude things here. So there's a few kind of cool functions of things I can do there. But I'm going to go back to my nice and simple bar chart there. Now I can kind of compare wines from different countries, and I'm going to run each of these guys here to just show how, that's just sort of making a quick graph here. But what's kind of nice here is I could say, well, I want to compare, I don't know, what did I have that on here? Spain, and update that and see the proportion of different, where the regions of these coming from. And in the United States, it's mostly Californian wines, some New York wines, and so on. So some nice sort of interactive graphics to explore the data. What I'm going to do now is I'm going to create a new table, wine reviews 130K target, but I'm going to remove the points attribute. So here I want to say, well, create a new table. Let me get that guy, show the editor. I'm going to create a new table, but I'm only going to pick some attributes in that. I don't really want to include points because I've got the points binned. So if I say I want to find a wine that's greater than 90 points, it's going to say, well, as long as the point scale is greater than 90, it'll be a 90 and above. It'll be sort of circular there. So I want to adjust the data to remove that as an input field. And now I want to show the data here just to make sure that the data, that I don't see that variable. And there are different data sets that are out there that also have the acidity and certain things. I actually have another version of this. I don't have those, but I also have another data set I'll be probably circling back with that has the wine reviews. So, the reviewer says, this is a very thin wine, it's acidic, and so on. And those words, because we also handle text mining capabilities with all the algorithms, those would be associated with maybe a not so good wine. And other terms like full-bodied and rich and robust, those might be associated with a better wine, at least for the taste of many people. So now I'm going to show the editor here. So now I am dropping the previous model settings, dropping the previous model, and I'm going to run this just for sort of repeatability purposes. And hopefully most of you SQL professionals are comfortable with that. I don't know if that ran or not, kind of ran fast there, so I'm going to run it twice, I guess. I'm going to have a model attribute settings table, which is really basically just you have to have a settings table. There's not much that we do in the attribute importance, but in the other algorithms, sometimes we do have a little bit more there. And now I'm going to run the attribute importance. I'll show this table up here. I'm going to do the attribute importance. So it's begin DBS data mining, create model. It's going to be an attribute importance type. The target field is the table is going to be this target field here, and the target field is going to be that points bin, and we're going to use the ID. So my belief and my observation is that most people familiar with Oracle technology can kind of follow this along. Now, we have templates to get you going, but we also are having graphical user interfaces coming along as well. And once I've created that output table, then I can go back here and just show the results of that. And there are the results. So I can see that somebody said, oh, surprise, surprise, price is the biggest factor. we could remove that, but I don't have that many variables here to use. I'm just trying to make this as an illustrative example for you. Region, variety, province, taster's name. These are all different from the set of data that I have. This is what I've been able to come up with. And now we're going to build a machine learning model. So we're going to use a random forest. And the code that we are going to use is I've taken the snippets out of the other examples and I've just modified them. So I'm going to drop the previous build settings. I'm going to drop the previous model. I'm going to drop the previous apply results for calculating the lift and the accuracy of the model. I'm going to split the data into a training and testing data set. This is very important, and I'm going to cover this more in some other webinars and different materials about how to do machine learning. Typically you take a randomly selected sample of the data of a certain amount, oftentimes 60% or 10% or whatever you want to do, but then you have a counter example, a holdout sample where you make predictions, and that's what I'm going to do here. Then I'm going to set up my settings table and populate it with I'm going to use the random forest. Now from a GUI I would say from the drop down menu just use say random forest, or from the AutoML user interface it would just pick that automatically really, or pick the best model is what we do there. I'm going to have auto data preparation on, which does a lot of automated things for data preparation, like replacing any missing values with the mean or the median and things like that, and a bunch of other functions. Then I'm going to build the classification model. So as you saw before, it's very simple syntax. Then I'm going to test the model on that holdout sample of data, and I'm done. And I'm just going to run this live here to show you that it really doesn't take too long. This is, what do we have, about 130,000 records here. I guess we're taking 60% of that for part of it, and then the other 60% we're sort of splitting the data here as we go through and do that. So we're setting up the data, we're building our models, we've applied the model, and at the end it says success, success, success. It's done all those different things. Now there are a lot of different things that you could do for model evaluation, and we're not going to get into all the different ones, but one way to do that would be a lift chart, sort of a cumulative gain. And I always like showing this. You could show this. A lot of people would show this as a line chart instead. I think it's kind of a little bit more visually appealing to see it this way. But that's my lift chart. I just run that, run this paragraph, and there's my lift chart. And what it says is 30% in, I found 60% of the good wines. So that's a pretty good model, okay? And there's a bunch of other different metrics, but it's the higher you can get this curve to, the higher you can get it all to come up all the way to here, the better it is. So this is a reasonably good model. If we had more variables, more attributes, we could do even more with it. Now we have our prediction, and we say, well, let me show me all the wines that are predicted to be a greater than 90 points. So we could also change this with these. You notice the little code I have here. One of the nice things about these notebooks is how I can have this interactivity here. So I can select. I have this little function here where I can say $sign and so on, and then insert a little nested picked list in here. So if I want to see just the wines that are likely to be 90% below 90 points, I can see them here. If I want to change that to greater than 90 points, it just sort of updates that. And I can see them all, and I can see the probability of them all. So it looks like I'd want to go after this one. It's a very good wine, and maybe I want to sort those in probabilities. But let's focus on the wines that have been picked to be greater than 90 points versus the bad wines over here. And I can say, well, here's also price and a few other things. So if I want to say the ones with the highest probability here of being a good wine, then I can take this guy and sort them. So here's a bottle of wine. It's a Holster Ranch, something that's greater than 90 points, but the price is $100. Okay, and it's from Edna Valley, and it's a Pinot Noir, and so on. So I can kind of go through this, and what I really am trying to do is sift through this. Something that has a reasonably high probability of being a good wine. So I want to get lower and lower and lower, but I can save more money if I can go down a little bit lower here. So I'm kind of sorting through this thing. I could sort based on one, sort based on the other, and keep on kind of drilling down. But we're getting into the realm where another visualization tool might be a useful thing to do as well. So what I'm going to do now is show the top 1,000 wines that are less than $15 and their predicted points. So I'm showing a bunch of wines that are really cheap wines, and they are predicted to be a good wine. So here's the candidates. Here's a bunch of candidates here that I can visualize, but they're coming from the United States, they're coming from Portugal, they're coming from New Zealand and various places. So I'm onto something here, but at this point I'm going to cut over and I'm going to use a very wonderful tool that's very complementary to Oracle Autonomous Database and Oracle Machine Learning algorithms that are embedded in the database. I'm going to use Oracle Autonomous Oracle Analytics Cloud. Oracle Analytics Cloud. So the first part of this, see how easy the machine learning can be inside the Autonomous Database. Celebrate with a fine glass of wine. But now, so good for you. You're on the verge of becoming an Oracle data scientist. But now let's investigate our insights and predictions a little bit further using the Analytics Cloud. So what we're going to do is we're going to remove any previous wine predictions table, and then we're going to see if I do this wine predictions table. And then I think I need to change that script. Okay, there it is. Okay, so now I'm going to create that table. Yeah, error. I think I have to drop that if it previously existed. I got to update that, but it does exist, and I already have it here. And so here's my table, and this is now the table, the wine predictions table, that I'm going to jump over to OAC and continue on. So for that point, for the rest of this presentation, I'm going to go over to sort of PowerPoint. I'm going to cheat a little bit, go over to PowerPoint, just really on the idea of sort of saving some time here. So here's some of the different graphs I was looking at before, and we get down to the end here. This is just about where we left off. And now I'm going to jump over to the Oracle Analytics Cloud. And this is the fine work that I did with Sudesh and Devani, and where they take all of the wines and they show the average price of the wine by country. So you can see the price is getting a little, the darker it is, the price goes up, and you can see the different countries. So the prices of wine are going up or down. And here they have the average price of the wine by province. So you don't have wine growing in all these different places. It kind of is centered in different provinces. So you see the price of the wine, and I believe the size of the bubble is related to the cost of the wine, I think is what's going on here. And so here I share the share of wines by price and country. So you can see the United States has the largest amount of wines, and you see the price, and you see the it's hard to read what's down here, the ID, I guess. But I can see France, I can see Italy. I can kind of drill down through here. But we've also done some machine learning. So we're getting ready to go look at that. Here are the wines with greater than 90 points by price and by country. So now we're going to continue on, and we're going to look at using Oracle Analytics Cloud. We're going to try and see, well, where are the wines that have a prediction of greater than 90 points? And you can kind of see they're in the United States, they're in certain places, and you can also see the price of these wines. So there's some more expensive wines here, and we're going to drill down and see the prediction of the greater than 90 points with a probability of greater than 70%. So the idea here is if I hover my mouse over this goes to, like, the Provence area, this goes to certain areas of Italy and certain areas of Spain, and we kind of drill in with the map and using all of Oracle Analytics Cloud's capability to kind of focus in on the wines. But which wines? The wines that we predict are the best wines. So now we want to do a little bit further sort of investigation. We're going to line up one pane on the left with Oracle Analytics Cloud versus another pane on the right. And we can see where are all the wines that are not predicted to be so good. We can see their country and their price. So the price is the color. Okay, the intensity of the color is a higher price. So the really bad wines that are really cheap are maybe coming from certain countries here, but the other wines that are predicted to be the better wines, they're coming with different regions. And if I have this live, I can drill through and see which country and see this on the map, or see this a variety of different ways. But I'm trying to take this a little bit further and say, also, let me take all the wines that are predicted to be very not so good wines, and I can see what the type of wines, where they're coming from, and the breadth, the different kinds of wines. And if I want to see the wines that are the predicted to be very, very good wines by their variety, I can see the Syrahs, which I love Syrahs, they're great. The Gamay, the different wines that are predicted to be the best wines, but also I have a trade-off of a price here. So if I want to have a very, very good wine, but a higher price, I'm going to be paying for certain champagnes and some Pinot Noirs and so on. But it looks like I can get away with certain wines over here that have a lower price, but also a good probability of being a good wine. So they're above 7. The threshold I did here for this graphic was above 70% probability. And so finally, if I drill through this even further, and Sudesh and Devani do such a good job of drilling through this live, then I can come through here and I can say, well, just show me the top 6 wines here. Let's see what we can get away with. And I can walk in with a 61% likelihood of being a 90-point or above wine for $30 here. So that's pretty good. And I'm coming in with a bottle of wine from whatever the name of it is. It's from Andalusia, Spain. sounds impressive. I can come up with that wine. Maybe I want to say I found something in British Columbia. Now that's 40 points. If I really want to have a spend a little bit more, I can do that. But look at for 35 points, 61% probability of being a pretty good wine. I found something I think is at least reasonable. So there's our sort of punchline. And now the next thing is, well, can we operationalize this? Can we take this even further? So let's continue on about on that. One option, I can export the models using a standard import or export model feature, which it offers a lot of capabilities, and I can kind of hook that up to something. But my ultimate goal here is to build a real-time wine application, wine recommendation application, maybe on my open dining table application, something like that. So I go into a restaurant and I kind of enter in, oh, here's a bottle of wine. I don't have scanning of the label and all that these days. Many apps do that. I'm just kind of trying to show a very simple example where I would now say, here it's a wine from Spain. It's from this variety, this vineyard. It's for $35 and so on, using the same input variables, and I would be able to build show a predictive model. But how do we go off and do that? Well, and this is now cutting over to Brendan Tierney from Oralytics, his most excellent work. He goes through and shows how from the Autonomous Database, I would go into the development aspect of this and launch Oracle Application Express. And once I'm in Oracle Application Express, I log in, and we're going to show how we take that model. I'm going to launch the RESTful services here in Oracle Application Express. And then Oracle Application Express says, hey, your schema that you're about to use here, it's not real. I don't know what this is. So you do go through this process of registering your schema. So now the REST services are available to be used on your schema that you've been working with. And what he does is he points out that there are a number of different helpful templates that are provided with Oracle Application Express. And that's what he's done here. He's taken one of these example templates in Oracle Application Express for these RESTful services. And he has one that, I skipped over much of the more detail of exactly how he's changed the code and so on. But he basically takes the code from the example and puts the model that was created through the Oracle machine learning algorithms into the RESTful API call. And at the end, he's got his predictions popping up here. So I know I'm glossing over something he covers in much greater detail, but I do want to show how that's done. And at the end, now, congratulations, you are a data scientist. Hopefully, I've been able to show how you can, explore your data, build a model or two, an attribute importance, a classification model, do that all using templates and using sort of straightforward code, using standardized kind of machine learning approaches or techniques to apply the models, leave the results in the database, and then visualize them using Oracle Analytics Cloud perhaps, and maybe even deploy them out into some sort of application, all using the Autonomous Databases as your platform that undergirds your larger operations. So it's a nice way for Oracle technical professionals to leverage and extend their vast skills and add a little bit more value by harnessing the power of the machine learning algorithms that come embedded in the database. If you want more information on this, you can, of course, go to the Oracle, you just Google Oracle Machine Learning on OTN. And I also like to call everyone's attention to these annual gatherings that we have. The next one will be in February 2020, the Analytics and Data Summit. And you're welcome to come join that. We currently, as of the moment I'm recording this, have our call for speakers is still open. So if you hear this right away, hopefully you can submit something. And thank you very much for doing this. I also should acknowledge Sadesh and Devani for their fine contribution for the Oracle Analytics Cloud portion of this. And again, thank you very, very much. You can follow us on Twitter, and thank you.